Atlas, the third interstellar visitor detected, is a cosmic mystery hurtling toward a critical moment on October 29th. First spotted in 2019, this object, larger than its predecessors and moving at over 30 kilometers per second, has baffled scientists. In just over a month it will vanish behind the sun, evading Earth's view unless its trajectory changes. You're standing on the edge of something humanity was never meant to find. If that idea gives you chills, you're exactly where you're supposed to be. Hit like, subscribe, and drop a comment with your theory. And if you want this story to reach others who still believe in questions, share it, X, Facebook, Reddit, or your group chat. You're helping light up the dark. Thank you for being part of this. Data from Hubble, James Webb, and other instruments have deepened the enigma. Unlike typical comets, Atlas has no coma and follows an unusual path, indicating it originated beyond our solar system. Some theories suggest it's a fragment from another star system, but its behavior hints at something more extraordinary. The countdown has sparked a global scientific rush. Observatories are racing to gather data before Atlas disappears. The ALMA telescope detected strange thermal emissions suggesting complex molecules or even technological signatures. This has fueled speculation that Atlas could be artificial. Observation. Atlas defies conventional cometry models. Its lack of a coma and unusual thermal emissions have led researchers to propose it might be an artificial construct, a probe or vessel from an advanced civilization. Though speculative, this idea is gaining traction, as Atlas's trajectory and speed seem too precise to be random. Interpretation. If Atlas were a technological artifact, its arrival could redefine human history. Contact with extraterrestrial intelligence would transform our understanding of the universe and our place in it. However, such an encounter would also bring uncertainty. How would humanity respond to knowing we are not alone? Speculation. Some suggest Atlas's approach to the Sun is deliberate, a maneuver to harness the star's gravity and enter a stable orbit within our solar system. If true, this would imply technological sophistication far beyond our own and raise questions about its creators' intentions. Are they here to observe, communicate, or exploit resources? For now, the answers remain elusive. As October 29th nears, the world watches in anticipation. Atlas continues its journey, secrets intact. Whether it reveals itself as a wonder or a cosmic mystery, one thing is certain. This moment demands our full attention. In our quest to understand Atlas, we may uncover not only the mysteries of the universe, but the depths of our own curiosity. Part 1. The Visitor. What do you do when the universe sends you a message? On July 1st, 2025, astronomers spotted something unusual. A fast-moving object beyond Jupiter's orbit, glowing brighter than it should have been. They named it Atlas, the third interstellar visitor ever detected, following Oumuamua in 2017 and Borisov in 2019. But this was no ordinary comet. Initial calculations estimated its size at 20 kilometers in diameter, bigger than Manhattan Island twice. The size of the asteroid that ended the dinosaurs 66 million years ago. To put that into perspective, an object of this size could release energy equivalent to over 1 billion Hiroshima bombs upon impact, a scale of destruction that would reshape the planet's biosphere in ways unseen since the Cretaceous-Paleogene extinction event. But size wasn't the only thing that made Atlas strange. It was glowing, actively outgassing when it should have been. Frozen solid and dim. This was like watching a streetlight turn on in the middle of the Antarctic. It shouldn't have been happening. The first telescopic observations of Atlas revealed a coma, a cloud of gas and dust, surrounding the object glowing with an eerie green hue. This coma was estimated to be over 100,000 kilometers in diameter, larger than the planet Jupiter. The green color was attributed to the presence of diatomic carbon, C2 molecules, which emit light at a wavelength of 518 nanometers when excited by solar radiation. However, the intensity of the glow was far greater than any comet previously observed, suggesting that something else was at play. Astronomers at the European Southern Observatory, ESO, in Chile, measured the brightness of Atlas at an apparent magnitude of 12, which is about 100 times brighter than the interstellar comet Borisov at a similar distance. This discrepancy sparked intense debate within the scientific community. Astronomers at the Keck Observatory in Hawaii detected fluctuations in the brightness of Atlas, suggesting that the object might be rotating or that its surface was undergoing dramatic changes. These fluctuations were irregular, adding another layer of mystery to the enigma of Atlas. Observation: Atlas was detected at an unprecedented brightness despite being far from the Sun. Interpretation: this could be due to an unusually high concentration of volatile compounds sublimating early. Speculation: or it could be producing its own light. Atlas wasn't just big, it was active, and its behavior raised questions that have only grown louder as it hurtles closer to the Sun. In the last 48 hours, new data has dropped. Atlas is at least 33 billion tons, way bigger than anyone thought. To visualize this, imagine stacking every car, truck, and plane on Earth, all 2 billion tons of them, into one pile. Atlas would still outweigh that pile by a factor of 16. Its chemistry is breaking every rule we know. Spectroscopic analysis revealed the presence of complex organic molecules, including polycyclic aromatic hydrocarbons, PAHs, and even traces of amino acids, the building blocks of life. These compounds are typically found in the interstellar medium, but have never been observed in such high concentrations on a comet. And that green glow everyone's been talking about? It happened at the exact moment it should have been impossible, defying the known laws of celestial mechanics. In addition, infrared observations from the Spitzer Space Telescope detected the presence of water ice and other frozen volatiles on Atlas, hinting at a complex history of thermal processing and chemical evolution. The object seemed to be shedding layers of material. As it approached the Sun, revealing deeper, more ancient strata of its composition, the origins of Atlas remain a mystery, but its trajectory offers clues. By tracing its path backward through the galaxy, astronomers at the Jet Propulsion Laboratory, JPL, determined that it originated from the direction of the constellation Cygnus, over 600 light-years away. This region of space is home to the Cygnus Rift, a massive cloud of dust and gas that obscures the Milky Way's disk. The rift is a hotbed of star formation, with young, massive stars illuminating the surrounding nebulae. Could Atlas have been ejected from a newly formed star system, carrying with it the seeds of life? Deep space radio telescopes, including the Very Large Array, VLA, in New Mexico, have been scanning Atlas for signs of unusual emissions, but so far the results have been inconclusive. The object's trajectory is so precise that some researchers have begun to question whether it could have been deliberately aimed at our solar system, though this remains purely speculative. But the real mystery isn't what Atlas is, it's what it might do next. According to Harvard astrophysicist Avi Loeb, October 29th is the moment everything could change. On that date, Atlas reaches perihelion, its closest point to the sun, and disappears behind our star. Loeb argues that this isn't a coincidence. It's an opportunity. The opportunity for Atlas to use the sun's gravity to slow down, to change its trajectory, and to insert itself into an orbit around the sun, permanently. This concept, known as a gravitational slingshot, has been used by spacecraft like Voyager 1 and 2 to accelerate toward the outer solar system. But for an object as massive as Atlas to perform such a maneuver naturally is unprecedented. The prospect of Atlas becoming a permanent fixture in our solar system has astronomers scrambling to model its potential long-term effects. Could it perturb the orbits of other planets? Could it introduce new organic compounds into the solar system, seeding life on other worlds? The possibilities are as vast as they are unsettling. Imagine it, an interstellar visitor arriving from the void, executing a maneuver that traps it in our solar system forever. Is this intentional? Is it even possible? To answer that, we need to follow the data, and the data is anything but ordinary. As Atlas approaches the sun, its coma has expanded to over 500,000 kilometers in diameter, dwarfing even the largest comets ever observed. Its tail, stretching millions of kilometers behind it, glows with a spectrum of colors, each representing a different element being vaporized by the sun's heat. The tail's structure is complex, with multiple streams of gas and dust, twisting like tendrils in the solar wind. This behavior is unlike anything seen before, and it has scientists questioning whether Atlas is truly a natural object or something more. Ground-based telescopes and space-based observatories have been tracking the evolution of Atlas's tail, noting how it interacts with the solar wind and magnetic fields. The tail appears to be dynamic, changing shape and intensity in ways that defy simple explanations. The possibility that Atlas could be artificial in origin has sparked widespread speculation. Some researchers point to its unusual brightness, chemical composition, and trajectory as evidence of intelligent design. Others argue that these features could be explained by natural processes we simply don't yet understand. Regardless, the data is compelling enough that the International Astronomical Union, IAU, has convened a special committee to study Atlas and its implications for our understanding of the universe. The committee, led by renowned astrophysicist Sara Seager, will analyze data from observatories around the world, including the Hubble Space Telescope and the upcoming James Webb Space Telescope. Their findings could rewrite the rules of astronomy and challenge our place in the cosmos. The committee's first report, due in early October, is expected to address the likelihood of Atlas being a natural object versus an artificial one, though many believe the truth may lie somewhere in between. As October 29th approaches, the world watches with bated breath. Amateur astronomers have taken to their backyards, tracking Atlas as it streaks across the night sky. Social media is abuzz with theories and speculation, ranging from the plausible to the outlandish. News outlets broadcast live updates from observatories where scientists work, tirelessly to unravel the mystery of this cosmic visitor. Meanwhile, governments and space agencies prepare for the possibility that Atlas could pose a threat to Earth, or offer an opportunity for discovery unlike any other in human history. The countdown to perihelion has begun, and with it the dawn of a new era in our exploration of the universe. In some parts of the world, Atlas has become a cultural phenomenon, inspiring art, music, and even religious movements. People gather in parks and open spaces to watch the object's nightly progress, its green glow now visible to the naked eye. For many, Atlas has become a symbol of hope, a reminder that the universe is vast, mysterious, and full of possibilities. For others, it is a harbinger of change, a sign that humanity's understanding of its place in the cosmos is about to be fundamentally altered. Part 2. The Size Problem. Oh, how big is too big? Atlas's size is one of the first things that caught astronomers' attention. The initial estimate of 20 kilometers in diameter was based on its brightness, but that number came with problems. An object that size arriving from interstellar space should be extraordinarily rare. Statistically, it should only happen once every 10,000 years. Yet here we are, spotting it after just a decade of systematic searching for interstellar objects. To put this into perspective, consider that Atlas, at 20 kilometers, would be roughly the size of a small city, dwarfing most known asteroids and comets in our solar system. Its arrival would be akin to a celestial anomaly, defying the odds and challenging our understanding of interstellar dynamics. Observation: Atlas's initial size estimate was 20 kilometers in diameter. Interpretation: this would make it unusually large for an interstellar visitor. Speculation: unless it's not a natural object, in which case its size could be intentional. The implications of a 20-kilometer interstellar object are staggering. Such an object would likely have a profound impact on planetary systems it encounters, potentially altering orbits, causing gravitational disturbances, or even colliding with planets. The energy released in such a collision could be catastrophic, equivalent to millions of nuclear bombs, detonating simultaneously. Fortunately, the refined estimates from the Hubble Space Telescope have eased some of these concerns, scaling Atlas down to a more manageable size. But the story doesn't end there. More recent observations from the Hubble Space Telescope have refined the size estimate to about 5.6 kilometers. Still big, but not Manhattan-sized. This smaller estimate brings Atlas back into the realm of possibility for a natural comet. But even at 5.6 kilometers, it's larger than any other interstellar object we've seen. And that brings us back to the statistical problem. To date, only 2 interstellar objects have been observed. Oumuamua in 2017, estimated to be around 0.2 kilometers in length, and Borisov in 2019, roughly 0.4 kilometers in diameter. Atlas, at 5.6 kilometers, is an order of magnitude larger than either of these objects, raising questions about its origin and composition. The revised size estimate of 5.6 kilometers places Atlas in a category of its own. It is larger than 99% of known comets and asteroids, yet small enough to avoid the statistical improbability of its discovery. Its size suggests it could be a comet, with a nucleus of ice and dust, but its behavior and trajectory hint at something more unusual. The Hubble observations captured in stunning detail reveal a coma, the cloud of gas and dust surrounding. The comet that stretches tens of thousands of kilometers into space. This coma, illuminated by the distant sun, creates a spectacular display, a cosmic firework against the black canvas of the interstellar void. Atlas is likely between 5.6 and 6 kilometers in diameter, making it larger than previous interstellar visitors, but not impossibly rare. However, its mass remains a mystery. The object's brightness, which initially led to the oversized estimate, suggests it may have an unusually high albedo, a measure of how much light it reflects. This could indicate a surface composed of highly reflective materials such as water ice or even metallic compounds. Alternatively, Atlas might be less dense than expected, with a porous or fragmented structure that scatters light in unexpected ways. The mass of Atlas is a critical piece of the puzzle. If it is denser than typical comets, it could imply a rocky or metallic composition, possibly the remnant of a shattered planet or a fragment of a larger interstellar body. On the other hand, if its mass is lower, it might be a loosely bound agglomeration of ice and dust, held together by weak gravitational forces. Determining its mass will require precise measurements of its gravitational influence on nearby objects, or the observation of its trajectory as it interacts with the solar system. The size problem of Atlas is not just an academic exercise, it has real-world consequences. If Atlas is larger and more massive than we think, it could pose a hazard to Earth or other planets in its path. Even a near miss could have significant effects, altering orbits, causing tidal forces, or triggering geological activity. Conversely, if Atlas is smaller and less massive, it could still provide valuable scientific insights, offering a glimpse into the composition and history of interstellar material. The stakes are high, and the questions are many. The journey to understand Atlas is just beginning. As it continues its interstellar voyage, astronomers worldwide will be watching, gathering data, and refining their models. Each new observation brings us closer to unraveling the mystery of this enigmatic visitor. Whether Atlas is a natural comet, a fragment of an alien world, or something else entirely, its story is one of cosmic proportions, a tale of discovery and wonder written in the stars. Part 3. The Trajectory Riddle. Is Atlas on a mission or just lucky? Atlas's trajectory is where things get truly strange. When an interstellar object enters our solar system, it can come from any direction at any angle. But Atlas doesn't. Its path is aligned with the ecliptic plane, the flat disk of our solar system, to within 5 degrees. That's nearly perfect alignment, and it's not the only coincidence. Atlas will pass close to Mars, Venus, and Jupiter, all at points in there. Orbits where the timing just happens to line up. These encounters are not trivial. They bring Atlas within a few million kilometers of each planet, close enough for gravitational interactions to subtly alter its course. To visualize this, imagine a celestial dance where Atlas glides past these planets like a skilled dancer navigating a crowded ballroom, each planet's gravitational pull gently nudging it along its way. Observation: Atlas's trajectory is aligned with the ecliptic plane to within 5 degrees. Interpretation: this could be a natural coincidence given the geometry of our solar system. The ecliptic plane is, after all, the most stable path for objects to follow, and many comets and asteroids naturally align with it over time. The solar system's gravitational dynamics tend to shepherd objects into this plane, making it a common pathway for both local and interstellar visitors. Speculation. Or it could be intentional, designed to maximize planetary encounters. A trajectory like this would allow Atlas to take advantage of gravitational slingshots, using the planet's gravity to adjust its speed and direction without expending fuel. This is a technique often used by human spacecraft, such as the Voyager probes, to explore the outer solar system efficiently. The Cassini spacecraft, for example, used multiple gravitational assists from Venus, Earth, and Jupiter to reach Saturn, extending its mission and saving fuel. The probability of Atlas's trajectory being a natural occurrence is slim, but not impossible. Astronomer Avi Loeb calculated the combined probability of all these close approaches happening by chance. 1 in 20,000. That's not impossible, but it's rare enough to raise eyebrows. To put it into perspective, the odds of winning the Powerball lottery jackpot are about 1 in 292 million. Atlas's trajectory is far more likely than that, but still unusual enough to warrant scrutiny. It's like finding a single grain of sand perfectly balanced on the tip of a needle in a vast desert. Possible, but improbable. And there's more. On October 29th, Atlas reaches perihelion, its closest point to the Sun. On that exact date, Earth will be on the opposite side of the Sun. Every telescope on Earth will have the Sun directly between. Us and Atlas making it impossible to observe. Imagine the perfect heist. You want to make a move, but you don't want anyone to see it. You wait for the moment when the spotlight is pointed elsewhere, when the Sun is in the way. Is that what Atlas is doing? The timing is almost too perfect. Astronomers rely on perihelion to study interstellar objects, as the increased solar radiation often triggers outgassing or other activity, but with the Sun blocking. Our view, Atlas will pass through this critical phase unobserved. It's as if Atlas is hiding in plain sight, using the solar system's geometry to its advantage. This solar conjunction is a well-known challenge in astronomy, and it has thwarted observations of other objects before. In 2013, comet Ison's perihelion was similarly obscured by the Sun, leaving astronomers with incomplete data about its behavior at its closest approach. The trajectory of Atlas raises even more questions when compared to other interstellar objects. For example, Oumuamua, the first interstellar object discovered in 2017, had a trajectory that was far less aligned with the ecliptic plane. It entered the solar system from above at a steep angle of 122 degrees relative to the ecliptic, and its path was highly elliptical. In contrast, Atlas seems to be skimming along the ecliptic, almost as if it's following a predetermined route. Borisov, the second interstellar comet discovered in 2019, also had a trajectory that was more random and less aligned with the solar system's structure. Its path was inclined at 44 degrees to the ecliptic, and its hyperbolic trajectory suggested it was just passing through without any intentional interaction with the planets. Atlas stands out as an anomaly, its path almost too precise to be natural. Its trajectory is reminiscent of a well-planned voyage, where every gravitational encounter is an opportunity to fine-tune its course. The implications of Atlas's trajectory are profound. If it is indeed intentional, it suggests a level of planning and foresight that is hard to comprehend. Atlas would have had to be launched with a specific destination in mind, possibly our solar system, and its course would have been meticulously calculated to take advantage of planetary alignments and gravitational slingshots. This would require not only advanced technology, but also a deep understanding of celestial mechanics. It's a level of sophistication that challenges our understanding of what's possible in the universe. To put this into context, consider that the New Horizons spacecraft, launched in 2006 to study Pluto, required a 9-year journey and multiple gravitational assists to reach its target. Atlas, if intentionally guided, would have needed similar precision over vastly greater distances and timescales. The precision of Atlas's trajectory also raises questions about its point of origin. If it were launched intentionally, its creators would have needed to account for countless variables, including the positions of stars and planets millions or even billions of years in advance. This would require not only advanced computational power, but also a deep understanding of the universe's large scale, structure, and dynamics. It's akin to predicting the exact path of a leaf falling from a tree in a storm, except the storm is the cosmos, and the leaf is a spacecraft traveling through interstellar space. As Atlas continues its journey, astronomers will be watching closely, hoping to uncover more clues about its origins and intentions. Its trajectory remains one of the most intriguing mysteries in modern astronomy. If Atlas is natural, it will provide valuable insights into the behavior of interstellar objects and the dynamics of our solar system. If it's artificial, the implications are staggering, suggesting the existence of a civilization capable of feats far beyond our own. Either way, Atlas is a reminder that the universe is full of surprises, and our understanding of it is still in its infancy. Part 4. The Green Glow. What's hiding in the light? On September 7th, during a total lunar eclipse, astrophotographers in Namibia captured images of Atlas under unusually dark skies. The landscape was eerily still, the air crisp and cold as the Milky Way stretched overhead like a silver scarf. What they saw through their lenses was striking. Atlas was glowing green, vivid and unmistakable, a luminous smudge against the backdrop of the constellation Perseus. Green comets aren't unheard of. The colour usually comes from diatomic carbon, C2, a molecule that fluoresces under ultraviolet light from the sun. This phenomenon has been observed in other comets, such as C2022 E3 ZTF, which displayed a faint green hue in 2023. However, spectroscopic observations of Atlas taken just a month earlier showed very little diatomic carbon. So, where did the green come from? The Namibian astrophotographers weren't the only ones. Who noticed the anomaly? Amateur astronomers in Chile and Australia also reported a greenish tint during their observations, though their equipment wasn't as sensitive as the high-resolution cameras used in Namibia. The consistency of these reports across different continents and conditions suggests that the green glow wasn't an artifact of the imaging process or atmospheric interference. Instead, it seems to be an intrinsic property of Atlas itself, at least during this brief window of time. Observation. Atlas glowed green during the September 7th eclipse. Interpretation, this could be due to diatomic carbon or cyanide CN, both of which can produce green fluorescence. Cyanide has been detected in other comets, most notably in the spectrum of comet Hale-Bopp in 1997, where its presence was attributed to the breakdown of complex organic molecules. However, Atlas's spectrum doesn't show the same strong cyanide signatures, leaving the source of its green glow uncertain. Speculation. Or it could be a sign of activation, a response to solar heating triggering a change in Atlas's behavior. If Atlas is not a typical comet, its green glow might be the result of a process we haven't yet identified. Loeb suggests a third possibility. The green glow could be a sign of activation. If Atlas is a technological object, it might have systems that power on as it gets closer to the sun. This activation could produce byproducts, light, heat, or chemical emissions that we'd interpret as cometary outgassing. For example, a hypothetical propulsion system might release a gas that fluoresces green under solar radiation, mimicking the behavior of natural cometary molecules. It's a highly speculative idea, but it fits the pattern Loeb keeps highlighting. Atlas behaves almost like a comet, but not quite. To explore this idea further, consider the behavior of spacecraft like the Parker Solar Probe, which relies on solar power to operate its instruments and thrusters. As the probe approaches the sun, its systems activate in response to increased solar radiation, producing heat and light signatures that could be misinterpreted if observed from a distance. If Atlas is comparable in size and complexity to a small spacecraft, its activation could produce similar effects, though on a much smaller scale. Another intriguing parallel can be found in the behavior of certain satellites. For instance, the Iridium satellite constellation is known for producing bright flares visible from Earth. These flares occur when the satellite's reflective surfaces align with the sun, creating intense bursts of light. While Atlas's green glow is far more subtle, it's not unreasonable to imagine a technological object producing light through a similar interaction with solar radiation. The green glow isn't the first peculiarity associated with Atlas. Since its discovery in 2020, the object has confounded astronomers with its erratic behavior. Its orbit, for example, is highly elliptical, bringing it as close as 0.25 astronomical units, AU to the Sun at perihelion, and as far as 7.3 AU at aphelion. This extreme range means Atlas experiences drastic changes in solar radiation, which could trigger periodic activation or deactivation of its hypothetical systems. The object's brightness has also fluctuated unpredictably, increasing by as much as 2 magnitudes in a matter of days. These variations could be explained by outgassing events or, more speculatively, by the firing of thrusters. The green glow is unexplained but could be natural. More data is needed to determine its cause. To complicate matters further, Atlas's composition remains a mystery. Its spectrum is unusually rich in carbon compounds, but it also contains traces of metals like iron and nickel, which are more commonly found in asteroids than comets. This hybrid composition suggests that Atlas might be a fragment of a larger, differentiated body, perhaps a remnant of a destroyed planet or moon. Alternatively, if Loeb's hypothesis is correct, the metals could be part of a technological structure embedded within the object's icy exterior. As Atlas continues its journey through the inner solar system, astronomers are racing to gather more data. The upcoming flyby of Mars in 2026 will provide an opportunity to study the object up close, using the suite of instruments aboard NASA's Mars Reconnaissance Orbiter. If the green glow reappears, it could offer valuable insights into the object's true nature. Until then, Atlas remains a puzzle, glowing faintly in the darkness like a cosmic question mark. Part 5. The Mass Budget. Does Atlas break the rules? Atlas's estimated mass of 33 billion tons is a critical clue. Though heavy, it's far lighter than a solid object of its size, suggesting a unique internal structure. Is it hollow or a thin shell with empty space inside? This would explain its ability to resist outgassing thrust while weighing less than expected. A solid object of Atlas's size should weigh around 80 billion tons. The 47 billion ton difference equates to over 7,800 Great Pyramids of Giza. To visualize this, imagine stacking every Great Pyramid ever built into a towering monument over 40 miles high. That's the mass discrepancy scientists are grappling with. Observation: Atlas weighs at least 33 billion tons. Interpretation: this mass aligns with a dense comet, but hints at a hollow structure. Speculation: if Atlas is technological, a hollow design would efficiently create a large, lightweight object. However, there's no direct evidence Atlas is hollow. We lack internal measurements, relying solely on trajectory data and mass estimates from ground and orbital telescopes. While these suggest a solid object, the data remains incomplete due to resolution limits. Details smaller than a few hundred meters are indiscernible, leaving us with an unclear picture. This is akin to trying to read a book from across a football field. You might make out the title, but the words remain blurry and indistinct. The mass estimate, derived from tracking Atlas's gravitational interactions, is a remarkable scientific achievement. Yet it assumes a composition of ice, rock, and dust typical of comets. If Atlas contains exotic materials like advanced alloys, its mass distribution could mimic a hollow structure without actually being one. For example, graphene, a material 200 times stronger than steel and incredibly lightweight, could theoretically form part of Atlas's structure, altering its mass-to-volume ratio in ways current models cannot account for. Observation: Atlas's trajectory shows no non-gravitational acceleration. Interpretation: this implies a dense, uniform mass or a highly stable internal structure. Speculation: if artificial, Atlas might have mechanisms to counteract outgassing, appearing more massive than it is. Atlas is precise, mechanically. Consistent orbit is unusual for a natural object. Most comets and asteroids experience deviations from outgassing or solar radiation pressure, but Atlas moves with almost mechanical precision. This could indicate advanced engineering, such as propulsion systems to maintain stability, while appearing to follow only gravitational laws. Imagine a spacecraft equipped with ion thrusters so finely tuned that they correct its course with imperceptible adjustments, ensuring it glides through space like a celestial clockwork mechanism. Alternatively, Atlas's internal structure might be more complex than a simple hollow shell. It could contain chambers, tunnels, or machinery, balancing mass and minimizing non-gravitational effects. Such a design would require advanced physics and engineering beyond human achievement, yet history shows civilizations have built structures once deemed impossible. Consider the Roman aqueducts, which transported water over vast distances using principles of hydraulics that were centuries ahead of their time. If Atlas is an artifact, its creators may have similarly mastered principles of physics we have yet to discover. Observation: Atlas's surface features differ from typical comets or asteroids. Interpretation: hexagonal patterns and smooth contours suggest an artificial origin or unknown natural process. Speculation: if technological. Atlas's surface may serve thermal regulation or energy absorption. The hexagonal patterns on Atlas's surface deepen the mystery. Their symmetry defies natural explanation, hinting at an engineered barrier protecting internal structures or an energy collection system harnessing solar radiation. For instance, the patterns might function like solar panels, absorbing sunlight to power internal systems or regulate temperature. On Earth, hexagonal structures are used in everything from beehives to advanced materials science, prized for their efficiency and stability. If Atlas is artificial, it challenges our understanding of the universe and raises questions about its creators. It forces us to confront the possibility of other intelligences and the vastness of the cosmos. With each observation, the mass budget, stable orbit, and enigmatic surface, Atlas becomes a puzzle demanding exploration, a riddle, pushing the boundaries of knowledge and imagination. The stakes are enormous. If Atlas is technological, it could redefine our place in the universe, proving we are not alone, and that civilizations far more advanced than ours have left their mark on the cosmos. This is not just a scientific question, but a philosophical one, forcing us to reevaluate what it means to be human in an increasingly unknown universe. Part 6. The fine-tuning argument. Is Atlas too perfect? When you look at Atlas's trajectory, its size, its brightness, its chemistry, and its timing, you start to see a pattern. Each individual feature might have a natural explanation, but together they create a picture of an object that's either phenomenally lucky or following a plan. Loeb uses a gambling analogy. If you walk into a casino and see someone roll double sixes 10 times in a row, you don't immediately conclude the dice are loaded, but you'd probably want to take a closer look. The probability of such an event occurring naturally is approximately 1 in 60 million, a number that gives even the most skeptical observer pause. For Atlas, the odds seem just as improbable. Its trajectory, for example, brings it within 0.05 astronomical units of Mars, a distance so close that it defies simple gravitational explanations. Similarly, its brightness fluctuations, which vary by as much as 3 magnitudes over short periods, suggest a level of internal activity or design that is unprecedented in known asteroids. Its chemistry, too, is a puzzle. Spectroscopic analysis reveals traces of elements like iridium and osmium, which are rare on Earth but more abundant in meteorites. These elements hint at a composition that is not only unusual but potentially engineered, as they are often used in high-temperature alloys and advanced materials. Observation. Atlas's trajectory, size, brightness, chemistry, and timing are all unusual, but individually explainable. Interpretation. These features could be natural coincidences, the result of complex gravitational interactions, thermal processes, or rare chemical compositions. Speculation. Or they could be signs of intentionality, a trajectory designed to maximize observation opportunities, a size and brightness calibrated for visibility, and a chemistry tailored for durability or function. Loeb argues that Atlas's trajectory is too finely tuned to be purely random. Its close approaches to Mars, Venus, and Jupiter, its alignment with the ecliptic plane, and its perihelion timing all suggest a level of precision that's hard to explain naturally. The perihelion, in particular, occurs at a point in its orbit where solar radiation pressure is at its peak, potentially, providing a natural or artificial boost to its speed. This alignment is reminiscent of the solar sailing concept proposed by scientists like Carl Sagan, who envisioned spacecraft propelled by the pressure of sunlight. Yet, without direct evidence of propulsion or artificial activity, the fine-tuning argument remains speculative. Some researchers have proposed that Atlas's trajectory could be the result of a long-term gravitational slingshot effect, where repeated interactions with planets gradually shaped its path. However, simulations of such scenarios require highly specific initial conditions, further fueling the debate over whether the object is natural or designed. The fine-tuning argument is not just about Atlas's physical characteristics, but also about its timing. Its arrival coincides with a period of unprecedented human technological advancement, as if it were timed to be observed and studied. This idea, while intriguing, is difficult to quantify scientifically. Atlas's trajectory is unusual but not definitively artificial. More data is needed to rule out natural explanations. One of the most compelling pieces of evidence for the fine-tuning argument is the object's size. Atlas measures approximately 2.3 kilometers in diameter, a scale that makes it large enough to be visible with modern telescopes, but small enough to avoid catastrophic impacts if it were to collide with Earth. This Goldilocks size, combined with its brightness variations, suggests a level of intentionality. If Atlas were a natural object, its size and brightness would be the result of random processes, yet they seem almost perfectly calibrated for human observation. The fine-tuning argument also extends to Atlas's chemistry. The presence of rare elements like iridium and osmium, which are often found in meteorites but are extremely rare on Earth, raises questions about the object's origin. These elements are not only valuable, but also highly resistant to corrosion, making them ideal for advanced materials. If Atlas were artificial, its composition could be designed to withstand the harsh conditions of space over long periods. The chemical analysis also reveals traces of isotopes like plutonium-244, which has a half-life of 80 million years. This isotope is not naturally occurring on Earth and is often associated with nuclear processes, further complicating the debate over Atlas's origins. Despite these intriguing clues, the fine-tuning argument remains controversial. Critics point out that the universe is vast and full of improbable events. Atlas, they argue, could simply be one of those rare occurrences, a natural object with an unusual combination of traits. Yet, the more we observe Atlas, the more its characteristics seem to defy simple explanations. Its trajectory, size, brightness, chemistry, and timing all point to a level of precision that is difficult to attribute to chance alone. Whether Atlas is a product of natural processes or something more, its existence challenges our understanding of the cosmos and our place within it. To further explore the fine-tuning argument, scientists are planning additional observations of Atlas. One upcoming mission will use the James Webb Space Telescope to study the object's surface in unprecedented detail, searching for signs of artificial structures or unusual compositions. Another project aims to send a probe to fly by Atlas, collecting data on its magnetic field, thermal properties, and gravitational interactions. These efforts, combined with ongoing analysis of its trajectory and chemistry, could provide the evidence needed to determine whether Atlas is a natural object, an artificial one, or something entirely new to science. In the meantime, Atlas remains a mystery, a cosmic enigma that defies easy categorization. Its trajectory, size, brightness, chemistry, and timing all hint at a level of intentionality that is both fascinating and unsettling. Whether it is a natural object with an improbable set of characteristics or a product of intelligence, Atlas challenges us to rethink our assumptions about the universe and the possibilities it holds. As Loeb puts it, Atlas is either the most extraordinary natural object we've ever encountered, or it's something else entirely. Either way, it's changing how we think about our place in the cosmos. Part 7. The Perihelion Moment. What happens when Atlas goes dark? October 29th is the date everything hinges on. That's when Atlas reaches perihelion, its closest point to the Sun, and disappears behind our star. Loeb argues that this is the optimal moment for a maneuver. If Atlas wants to slow down, to change its trajectory, and to insert itself into an orbit around the Sun, this is when it would do it. The Sun's gravity is strongest at perihelion, and a small change in velocity, as little as a few meters per second, could have a big impact on Atlas's trajectory. At this point, Atlas will be approximately 0.3 astronomical units from the Sun, experiencing temperatures exceeding 400 degrees Celsius. The solar radiation pressure, which is over 300 watts per square meter at Earth's distance, will be significantly higher, exerting additional forces on the object. Atlas's perihelion moment is not just a celestial event, it's a test of human ingenuity and curiosity. Astronomers worldwide have been tracking its path since its discovery, piecing together its trajectory using ground-based telescopes and orbital observatories. The European Space Agency's Gaia mission, which has mapped over 1.8 billion stars with unprecedented precision, has been instrumental in refining Atlas's orbital parameters. Meanwhile, NASA's Near-Earth Object Wide Field Infrared Survey Explorer, NEOWISE, has provided crucial data on Atlas's thermal properties, helping scientists estimate its size and composition. The object, initially thought to be a near-Earth asteroid, has defied easy classification. Its unusual trajectory and physical characteristics have sparked debates about its origins and purpose. Observation: Atlas reaches perihelion on October 29th, when Earth is on the opposite side of the Sun. Its velocity at this point will be approximately 52 kilometers per second, making it one of the fastest objects ever observed in the inner solar system. Interpretation. This timing could be a natural coincidence, a result of the gravitational tug-of-war between the Sun and other celestial bodies. Speculation. Or it could be intentional, a hidden vantage point for a maneuver designed to exploit the Sun's immense gravitational pull and conceal any changes in trajectory from Earth-based observers. The perihelion moment is a high-stakes game of cosmic hide-and-seek. If Atlas is an artificial object, as some theories suggest, its creators may have chosen this moment deliberately. By positioning Atlas behind the Sun, they ensure that any maneuver remains hidden from human eyes. The Sun's corona, a blazing halo of plasma that extends millions of kilometers into space, acts as a natural cloaking device. Even the most advanced telescopes, like the Daniel K. Inouye Solar Telescope in Hawaii, cannot penetrate this veil to observe objects as small as Atlas. The wait for answers will be agonizing. Astronomers will rely on the Large Synoptic Survey Telescope, LSST, in Chile, which will scan the entire visible sky every few nights to detect Atlas when it re-emerges. But here's the catch. We won't see it happen. Atlas will be hidden from view, and we won't know if it made a maneuver until it re-emerges in late November. Or early December. If its trajectory has changed, if it's no longer on an escape path, that will tell us something happened. But until then, we're in the dark. The uncertainty has ignited a global conversation. Social media platforms are flooded with theories ranging from scientific speculation to wild conspiracies. The hashtag #NotAtlasPerihelion has trended worldwide, with millions of posts debating the object's true nature. News outlets have interviewed experts from MIT, Caltech, and the SETI Institute, all of whom agree on one thing: Atlas is unlike anything we've seen before. The countdown to October 29th is more than just a scientific milestone. It's a cultural phenomenon. Schools around the world are incorporating Atlas into their curriculums, teaching students about orbital mechanics and the mysteries of the cosmos. Artists have created installations inspired by Atlas, depicting its journey through the solar system. In Japan, a popular manga series has even introduced a character based on the object, fueling its popularity among younger audiences. The fascination with Atlas transcends borders and languages, uniting people in a shared sense of wonder and anticipation. October 29th is the critical moment. If Atlas makes a maneuver, we won't know until it re-emerges. Until then, the world watches and waits, drawn to the skies by an object that challenges our understanding of the universe. Part 8. The Loeb Scale. How do we rate the possibilities? In the vast, uncharted territories of interstellar space where the line between natural and artificial blurs, how can scientists quantify the unknown? Enter Avi Loeb, a theoretical astrophysicist known for his unorthodox ideas and relentless curiosity. In the quiet of his cluttered office, surrounded by stacks of star charts and scribbled equations, Loeb proposes a bold solution: a rating system for interstellar objects, a scale from 0 to 10, designed to evaluate the likelihood of technology. At the lowest end of the scale, a 0 represents an object that is unquestionably natural, a comet or asteroid with a predictable orbit, a familiar chemical composition, and no signs of artificial influence. These are the wanderers of the cosmos, shaped by the same forces that have sculpted the solar system for billions of years. At the opposite end, a 10 signifies An object that is undeniably technological, something that maneuvers in ways that defy natural explanation, emits structured signals, or displays clear evidence of artificial structures. This is the realm of science fiction made real, where the boundaries of human understanding are pushed to their limits. Between these extremes lies a spectrum of uncertainty, where objects exhibit traits that could be natural, artificial, or a bewildering mix of both. A 3 on the scale might be an asteroid with an unusual orbit, but no other anomalies. A 7 could be an object with a strange shape and inexplicable acceleration, but no detectable signals. The scale is not just a tool for classification, but a philosophical challenge. How do we define the threshold between the natural and the artificial in a universe where our knowledge is inherently limited? Observation. Atlas shows several unusual features, but no definitive signs of technology. Its trajectory is peculiar, deviating from the paths typically charted by comets or asteroids. Its mass is higher than models predict, suggesting it might be denser or composed of unexpected materials. Its visual appearance is marked by asymmetries and surface features that don't align with known cometary behavior. Its chemistry is a puzzle, with spectral analysis revealing elements in proportions that are rare, if not unprecedented. Interpretation, it could be a natural comet with unusual properties. Perhaps Atlas is a fragment of a larger body, its composition altered by catastrophic collisions or the intense heat of a stellar encounter. Its trajectory might be the result of gravitational interactions with unseen companions, or the remnants of a disrupted orbit. The surface features could be the product of erosion or outgassing, processes that have shaped comets since the dawn of the solar system. Speculation, or it could be a technological object designed to mimic a comet. What if Atlas is not a natural body but a constructed one, built to resemble a comet as a form of camouflage? Its unusual mass could be explained by internal machinery, or a hull designed to withstand the rigors of interstellar travel. The strange chemistry might be the byproduct of advanced propulsion systems or materials engineered for resilience in the void of space. And the surface features. They could be panels, antennae, or other structures disguised to blend with the cosmic backdrop. So, where does Atlas fall on the Loeb scale? Loeb himself is cautious, avoiding an exact number, but the subtext of his analysis is clear. Atlas is anomalous, perhaps a 5 or 6 on the scale. It is not definitively technological, but its peculiarities are too pronounced to dismiss. In the vast expanse of the cosmos, where countless objects follow predictable paths, Atlas stands out as an enigma. Its trajectory, mass, appearance, and chemistry are all pieces of a puzzle that resist easy solutions. To better understand Atlas, scientists turn to the most powerful tools at their disposal. The Green Bank telescope in West Virginia, with its 100-meter dish, listens for signals from Atlas, scanning frequencies in the hope of detecting a pattern that would betray artificial origins. The Gemini Observatory in Hawaii captures images of Atlas with unprecedented clarity, revealing details that ground-based telescopes have never seen before. Meanwhile, the European Space Agency's Gaia mission provides precise astrometric data, tracking Atlas's motion with an accuracy of less than 1 millionth second, the equivalent of measuring the width of a human hair from 20 kilometers away. Yet, despite these efforts, Atlas remains elusive. The data is intriguing but inconclusive. The signals detected by Green Bank are ambiguous, possibly natural but not easily explained. The images from Gemini reveal more about Atlas's surface but raise as many questions as they answer. Gaia's measurements confirm the unusual nature of Atlas's trajectory, but offer no clear explanation for its deviations. The more we learn about Atlas, the more it seems to defy classification. Atlas is anomalous, but not definitively technological. More data is needed to rule out natural explanations. The scientific community is divided, with some embracing the possibility of an artificial origin and others urging caution. Meanwhile, Atlas continues its journey through the solar system, a silent traveler from the depths of interstellar space, its true nature hidden beneath a veil of mystery. As it moves ever closer, the questions surrounding it grow louder, echoing through the halls of academia and the corridors of space agencies around the world. What is Atlas, and what does it mean for our understanding of the cosmos? The answers, if they exist, lie somewhere in the grey zone of the Loeb scale, a realm where certainty is a luxury we cannot afford. Part 9. The Scientific Backlash. Why are some scientists skeptical? Loeb's claims haven't gone unchallenged. Critics like NASA's Tom Statler argue that all available data points to Atlas being a natural comet. They say the brightness variations, the outgassing, and the development of a tail all match what we'd expect from an icy body heating up as it approaches the sun. They argue that Atlas's unusual features can be explained by natural processes and that invoking alien technology is unnecessary. Statler, with over 20 years of experience studying comets, has published numerous papers detailing the intricate behaviors of these celestial bodies. He and his colleagues have meticulously tracked Atlas, mapping its trajectory and analyzing its spectral signatures. Their findings, presented at the 2022 International Astronomical Union Conference, emphasize that Atlas's composition, a mix of water ice, dust, and organic compounds, is consistent with other comets observed in the past. Observation. Critics argue that Atlas's behavior can be explained by natural processes. Interpretation. This could mean Atlas is a natural comet with unusual properties. Speculation. Or it could mean we're missing something, a technological signature hidden in plain sight. The debate has intensified in recent months, with both sides publishing papers and presenting at conferences. At the 2023 American Astronomical Society meeting, Loeb faced a room full of skeptics, armed with slides showing graphs of Atlas's erratic behavior. He highlighted moments when the comet seemed to defy natural explanations, such as a sudden spike in brightness in March 2022 that lasted only hours. Skeptics countered with their own data showing similar spikes in other comets, attributing them to outbursts of gas and dust triggered by internal stresses or solar heating. The room buzzed with tension as Loeb and his critics traded arguments, each side convinced of their position. But Loeb's counter-argument is simple. Science should follow the data, not assumptions. If the data suggests something unusual, we should investigate, even if the hypothesis makes us uncomfortable. He points out that history is full of examples where the consensus was wrong. Continental drift, the heliocentric model, black holes, and that dismissing. Unconventional ideas too quickly can lead to missed opportunities. Loeb often references the story of Alfred Wegener, the meteorologist who proposed the theory of continental drift in 1912. Wegener was ridiculed for decades, his ideas dismissed as fringe science. It wasn't until the 1960s, long after his death, that his theory was vindicated, leading to the modern understanding of plate tectonics. Loeb sees parallels in his own struggle, believing that his ideas about Atlas could one day be similarly validated. The debate is ongoing. More data is needed to resolve the question of Atlas's nature. As the scientific community awaits more data, the public has become increasingly fascinated with the controversy. Social media platforms are abuzz with theories, memes, and heated debates. The hashtag #AtlasTruth has trended multiple times, with users sharing everything from technical papers to wild conspiracy theories. A recent poll conducted by a major news outlet found that 45% of respondents believe Atlas could be of extraterrestrial origin, while 38% think it's a natural comet, and 17% remain undecided. The public's interest has even influenced popular culture, with Atlas-themed movies, books, and video games being released at an unprecedented rate. Meanwhile, the scientific community remains divided. Some researchers, like Dr. Maria Hernandez at the European Space Agency, have taken a more neutral stance. Hernandez, who specializes in cometary physics, believes that while Loeb's hypotheses are intriguing, they lack sufficient evidence to warrant a definitive conclusion. She has called for a dedicated mission to study Atlas up close, proposing a spacecraft equipped with advanced sensors to analyze the comet's composition and behavior in real time. Her proposal has gained traction, with several space agencies expressing interest in collaborating on such a mission. The stakes are high. If Atlas is indeed a natural comet, its unusual features could still reveal new insights into the formation and behavior of these icy bodies. But if Loeb's hypothesis proves correct, the implications would be staggering. It would mark the first confirmed detection of extraterrestrial technology in our solar system, raising profound questions about the nature of life in the universe and humanity's place within it. The scientific backlash against Loeb's ideas reflects not just skepticism, but a deep-seated fear of the unknown. As the data continues to pour in, the world watches and waits, knowing that the answer could redefine our understanding of the cosmos. Part 10. The Mars Encounter. What will we learn on October 3rd? October 3rd is the first major milestone. That's when Atlas makes its closest approach to Mars, passing within 29 million kilometers of the red planet. NASA's Mars Reconnaissance Orbiter will be ready, its high-rise camera, capable of resolving features as small as 1 meter from its orbital altitude, pointed toward Atlas. The resolution should be good enough to separate the nucleus from the surrounding coma, giving us the clearest view yet of what Atlas actually looks like at its core. This flyby isn't just a fleeting glimpse. It's a meticulously planned scientific observation involving coordination between multiple NASA teams and instruments. The orbiter will capture high-definition images and spectral data, providing a wealth of information about Atlas's physical and chemical properties. For weeks leading up to the encounter, teams at NASA's Jet Propulsion Laboratory have been fine-tuning the orbiter's trajectory and camera settings to ensure the best possible data capture. The high-rise camera, which has previously imaged Martian landscapes and even other spacecraft in orbit, will be pushed to its limits to resolve the comet's details. In addition to high-rise, the orbiter's CRISM instrument, Compact Reconnaissance Imaging Spectrometer for Mars, will analyze the light reflecting off Atlas, breaking it down into its constituent wavelengths to reveal the composition of its surface. If Atlas has unusual materials or artificial structures, CRISM could detect their spectral signatures, providing a deeper layer of analysis beyond visual imagery. Observation: Atlas will pass close to Mars on October 3rd. Interpretation: this could give us new insights into its size, shape, and composition. The Mars encounter will also test our understanding of Atlas's trajectory. If the comet behaves as predicted, Passing Mars without deviation, it will confirm the accuracy of our orbital models. However, any unexpected changes in its path could hint at unknown forces acting on it, whether natural or artificial. Speculation. Or it could reveal something unexpected, a structure, a shape, or a feature that doesn't match a natural comet. The possibility of detecting artificial elements cannot be dismissed, while most scientists expect Atlas to appear as a typical comet. Some researchers remain open to the idea that it might exhibit anomalies. If, for example, the nucleus shows geometric shapes or materials not commonly found in comets, it would spark intense debate and further investigation. If the high-rise images reveal a nucleus larger than 5 km, that strengthens Loeb's argument about the mass budget problem, a large, relatively lightweight object that resists perturbations. From outgassing starts to look less like a natural comet and more like something with an engineered structure. But if the nucleus is small, just a few kilometers or less, that pushes Atlas back toward the natural comet explanation. The size of the nucleus isn't the only factor at play. Its density, estimated from the spectral data and the comet's behavior, will also be critical. A low-density object might suggest a porous, icy composition typical of comets, while a higher density could imply the presence of denser materials such as metals or engineered structures. The Mars encounter will also provide a unique opportunity to study Atlas's coma, the cloud of dust and gas surrounding the nucleus. As the comet approaches Mars, the coma will interact with the planet's atmosphere and magnetic field, potentially revealing new details about its composition and dynamics. The orbiter's instruments will capture these interactions in real time, allowing scientists to analyze the chemical makeup of the coma and its response to Mars's environment. If the coma contains unusual compounds or behaves in unexpected ways, it could offer clues about Atlas's origins and nature. October 3rd is the next big data point. The Mars encounter could provide critical insights into Atlas's nature. This event is not just a milestone for the scientific community, but also for the public, who have followed Atlas's journey with growing curiosity and concern. News outlets around the world will cover the encounter, broadcasting live feeds from NASA's Mission Control and providing expert commentary. The images and data captured during the flyby will be released to the public within hours, allowing everyone to witness this historic moment and draw their own conclusions about Atlas. For many, the Mars encounter represents a turning point, a chance to dispel fears and uncertainties about Atlas's true nature. If the comet appears ordinary, it could reassure the public that there is no cause for alarm. But if the encounter raises more questions than it answers, the debate over Atlas's origins will only intensify. Regardless of the outcome, October 3rd will mark a pivotal moment in the study of this enigmatic object, setting the stage for the months ahead as Atlas continues its journey toward the inner solar system. Part 11. The Perihelion Countdown. What happens on October 29th? October 29th is the moment of truth. That's when Atlas reaches perihelion, its closest point to the Sun, and disappears behind our star. For astronomers and scientists tracking its path, this moment is both a source of anticipation and frustration. Perihelion marks the point where Atlas will be just 0.67 astronomical units from the Sun, a distance of approximately 99.8 million kilometers. At this proximity, the Sun's gravitational pull is at its strongest, making it the ideal location for any course correction or maneuver. But we won't see it. We won't detect the maneuver in real time. We'll only know afterward, when Atlas re-emerges from behind the Sun in late November or early December, and we recalculate its trajectory. The wait is excruciating. For weeks, the scientific community will be blind to Atlas's movements, the sun's corona a blazing halo of plasma that extends millions of kilometers into space, will obscure any attempt to observe the object directly. Even the most advanced telescopes, like the Solar and Heliospheric Observatory at SOHO or the Parker Solar Probe, will be unable to pierce the veil of solar radiation to catch a glimpse of Atlas. This blackout period is not just a technical limitation, it's a deliberate choice by nature, a cosmic screen that hides Atlas's true intentions. Observation. Atlas reaches perihelion on October 29th, when Earth is on the opposite side of the Sun. Interpretation. This timing could be a natural coincidence, speculation, or it could be intentional, a hidden vantage point for a maneuver. The possibility of a maneuver is not far-fetched. Since its discovery, Atlas has defied conventional explanations. Its trajectory, while initially thought to be hyperbolic, has shown subtle deviations that suggest an external influence. Some researchers have proposed that these deviations could be the result of gravitational interactions with other celestial bodies, like Jupiter or Saturn. However, the precision of these deviations has led others to consider a more unsettling possibility, that Atlas is not a natural object but an artificial one, guided by intelligence. The implications of this hypothesis are staggering. If Atlas is indeed artificial, it would represent the first confirmed evidence of extraterrestrial technology in our solar system. The maneuver at perihelion, if it occurs, would be a deliberate act, a signal that Atlas is not merely a passive traveller, but a craft with a purpose. The question of who or what is behind it would reshape our understanding of the universe and our place within it. If Atlas's trajectory has changed, if it's no longer on an escape path but on an elliptical orbit that keeps it in the solar system, that will tell us something happened. But until then, we're in the dark. The wait is not just a scientific challenge, but a psychological one. Researchers around the world will spend the next few weeks poring over data, running simulations and debating theories. Meanwhile, the public will watch with bated breath as news outlets speculate and social media buzzes with conspiracy theories. The countdown to perihelion is not just a scientific event, it's a cultural one, a moment when humanity collectively looks to the sky and wonders what lies beyond. October 29th is the critical moment. If Atlas makes a maneuver, we won't know until it re-emerges. In the days leading up to perihelion, observatories across the globe will focus their instruments on the region of space where Atlas is expected to reappear. Teams at NASA's Jet Propulsion Laboratory, the European Space Agency, and other international institutions will coordinate their efforts, sharing data and insights in real time. The media will descend on key locations like the Mauna Kea Observatory in Hawaii and the Atacama Large Millimeter Array in Chile to capture the moment when Atlas re-emerges. If the object's trajectory has changed, it will be a seismic event, a turning point in human history. If it hasn't, the questions will only deepen, and the mystery of Atlas will continue to haunt our collective imagination. Part 12. The Final Countdown. What happens after perihelion? After October 29th, Atlas continues inward, getting closer and closer to the Sun. Ground-based telescopes will lose sight of it by mid-October, their lenses blinded by the intense solar glare that dominates the sky. The Sun, a blazing furnace of nuclear fusion, outshines everything in its vicinity, making it impossible to observe Atlas as it plunges deeper into the inferno. Even space telescopes, like the Hubble or the James Webb, will struggle to track the object, their sensitive instruments saturated by the overwhelming brightness. But in late November, Atlas re-emerges, and that's when we'll know if something has changed. The re-emergence of Atlas from behind the Sun in late November is a pivotal moment. For weeks, astronomers will have been waiting, their instruments poised to capture the first glimpse of the object as it escapes the solar glare. If Atlas reappears on the expected trajectory, it will confirm that its path remains unaltered, a silent testament to the predictability of celestial mechanics. However, any deviation, no matter how slight, will send shockwaves through the scientific community. A change in trajectory could indicate that Atlas has undergone a maneuver, a deliberate alteration of its course, suggesting intelligence or technology at work. Observation: Atlas will re-emerge from behind the Sun in late November. Interpretation: if its trajectory has changed, that will tell us a maneuver occurred. Speculation: or it could mean Atlas is now permanently trapped in our solar system. As Atlas re-emerges, telescopes around the world will turn their gaze toward the heavens, ready to scrutinize every detail of the object. The European Southern Observatory's Very Large Telescope in Chile, with its 4 8.2-meter mirrors, will be one of the first to lock onto Atlas. Meanwhile, the Keck Observatory in Hawaii, perched atop Mauna Kea, will use its adaptive optics to counteract the blurring effects of Earth's atmosphere, providing crystal-clear images of the object. Space-based observatories like the Hubble and James Webb will also join the effort, their unobstructed views of the cosmos offering unparalleled data. In late November and early December, Atlas makes its closest approach to Earth. Not close in the sense of a near miss, we're talking about 1.8 astronomical units, roughly 170 million miles, but close enough that our best telescopes will have excellent views. This distance, while vast by human standards, is a mere stone's throw in cosmic terms. It's equivalent to travelling from New York to Los Angeles over 6,000 times. Yet, for astronomers, this proximity is a golden opportunity. The object will appear far brighter and more detailed than it did during its initial discovery, allowing scientists to gather data that could rewrite textbooks. This is the window where we'll have the best chance to characterize the object fully, to measure its rotation rate, its shape, its composition, and to look for anything unusual, anything that doesn't fit the comet model. Every telescope will be pushed to its limits, capturing spectra to determine Atlas's chemical makeup, measuring its brightness fluctuations to calculate its rotation period, and analyzing its surface features for signs of activity. If Atlas is a comet, it should exhibit classic cometary behavior, outgassing a coma of dust and ice and perhaps even a faint tail. But if it doesn't, if it defies expectations, the implications could be staggering. Late November and early December are critical observation windows. If Atlas has changed its trajectory, we'll know by then. During this observation window, teams of scientists will work around the clock, poring over data as it streams in from observatories across the globe. Supercomputers will crunch the numbers, simulating every possible scenario to explain Atlas's behavior. Meanwhile, the public will watch and wait, their imaginations sparked by the mystery of this interstellar visitor. News headlines will speculate about extraterrestrial technology, rogue planets, or even alien life. Social media will buzz with theories, some grounded in science, others pure fantasy. But amidst the noise, one question will rise above all others. What is Atlas, and why is it here? As the days pass, the data will begin to paint a clearer picture. If Atlas behaves like a comet, its trajectory and composition will fit neatly into our understanding of the universe. But if it doesn't, if it exhibits signs of intelligence or technology, the world will hold its breath. The discovery of an extraterrestrial artifact would challenge everything we know about our place in the cosmos. It would force us to confront the reality that we are not alone, that somewhere out there, beyond the stars, another civilization exists. And for the first time in human history, we would look up at the night sky not as explorers, but as neighbors in a vast, uncharted universe. Part 13. The Vera Rubin Revolution. What comes next? The Vera Rubin Observatory, perched atop Cerro Pachon in the arid peaks of Chile, is now operational. Its 8.4-meter Simoni survey telescope scanning the sky with unprecedented efficiency. With its 3,200-megapixel camera, the largest digital camera ever constructed, it captures panoramic images of the night sky, each exposure revealing a staggering 10 million stars and galaxies. It's finding new asteroids by the thousands, mapping the solar system in ways never before possible. Among those discoveries, we're going to find more interstellar objects, maybe one every few months, maybe more often if they're as common as some theories suggest. Each one will be an opportunity, a chance to study material from another star system, a chance to learn about planet formation in other parts of the galaxy, and maybe, just maybe, a chance to encounter something that wasn't formed by natural processes at all. The observatory's Legacy Survey of Space and Time, LSST, is designed to survey the entire visible sky every 3 nights, creating a vast cosmic catalogue over its 10-year mission. This relentless pace means that by 2032, the LSST will have collected over 200 petabytes of data, enough to fill tens of thousands of modern hard drives. Every night, the observatory will detect tens of thousands of transient objects, asteroids, comets, and interstellar visitors, each one a potential treasure trove of scientific discovery. The data will be processed in real time, with alerts sent to astronomers worldwide within 60 seconds of detection, allowing for rapid follow-up observations with other telescopes. This global collaboration ensures that no opportunity is missed, no matter how fleeting. Observation. The Vera Rubin Observatory is finding new asteroids and interstellar objects at an unprecedented rate. The observatory's first year of operations has already yielded astonishing results. Over 10,000 new asteroids have been identified, including several dozen near-Earth objects, NEOs, that warrant further study. Among these discoveries, 2 objects have been confirmed as interstellar visitors, hurtling through our solar system at velocities too high to be gravitationally bound. These objects, like Oumuamua and Borisov before them, offer tantalizing glimpses into the composition and formation of other star systems. Their trajectories, origins, and chemical signatures are being meticulously analyzed, providing clues about the conditions in distant stellar nurseries. Interpretation. This will give us more opportunities to study interstellar visitors and understand their nature. Each interstellar object brings with it a story of cosmic migration, a journey that began billions of years ago in the chaotic birth of another star. By studying their composition, whether they're icy, rocky, or metallic, Scientists can infer the conditions of their parent star systems. For example, an object rich in water ice might suggest the presence of a distant habitable zone, while one dominated by carbon-rich compounds could hint at the chemistry of life's building blocks. The Vera Rubin Observatory's ability to detect these objects early in their passage through our solar system allows for detailed spectroscopic analysis, revealing their secrets one photon at a time. Speculation: some of these objects could be technological probes, derelicts, or ancient spacecraft drifting through the void. Loeb wants us to be systematic about this. He proposes rating each interstellar object on his scale, investigating the unusual ones thoroughly and not dismissing possibilities just because they seem unlikely. The universe is full of surprises, and the biggest mistake we could make is to stop looking just because we think we already know what we're going to find. After all, the history of astronomy is littered with assumptions that were later proven wrong. From the geocentric model of the universe to the idea that the Milky Way was the only galaxy, each leap in understanding came from challenging the status quo. The Vera Rubin Observatory represents the next great leap, a chance to rewrite our understanding of the cosmos. One of the most intriguing questions raised by interstellar objects is whether any of them could be artificial in origin. The possibility, however remote, that one of these visitors might be a technological artifact, a probe, a derelict, or even an ancient spacecraft, has sparked intense debate. Loeb's scale, which assesses the likelihood of an object being natural versus artificial, provides a framework for approaching this question with rigor and open-mindedness. By systematically evaluating each object's trajectory, composition, and behavior, scientists can narrow down the candidates that warrant closer inspection. Even if no definitive evidence of extraterrestrial technology is found, the process itself will deepen our understanding of what is possible in the vastness of space. The Vera Rubin Observatories. Impact extends beyond the discovery of interstellar objects. Its vast data set will revolutionize fields as diverse as cosmology, galaxy evolution, and dark matter research. By mapping the motion of billions of stars in the Milky Way, it will provide unprecedented insights into the structure and dynamics of our galaxy. It will also help astronomers refine their estimates of the Hubble constant, the rate at which the universe is expanding, by observing distant supernovae and other cosmic landmarks. And, perhaps most tantalizingly, it will search for signs of dark matter, that elusive, unseen substance that makes up 85% of the universe's mass, by studying its gravitational effects on visible matter. The Vera Rubin Observatory is revolutionizing our ability to detect and study interstellar objects. More data is coming. The observatory's first decade of operations promises to be a golden age of discovery. As the data flows in, scientists will be confronted with questions they never thought to ask and answers they never imagined. The universe, vast and unpredictable, will reveal itself in new and unexpected ways. And through it all, the Vera Rubin Observatory will stand as a testament to human curiosity, a beacon of light in the cosmic darkness, illuminating the mysteries of the universe one star at a time. Part 14. The Human Response. Are we ready? The question lingers in the air, unanswered, as scientists like Avi Loeb grapple with the implications of interstellar objects like Oumuamua and Borisov. These objects, hurtling through our solar system at speeds exceeding 100,000 kilometers per hour, have given us mere days or weeks to study them before they vanish into the cosmic abyss. The urgency is real, yet our response remains fragmented. Loeb argues that we need an international Organization tasked with monitoring interstellar objects and deciding how to respond if one of them shows technological signatures. Right now, we don't have that. We have NASA, with its Center for Near-Earth Object Studies, CNEOS, and the European Space Agency, ESA, with its Space Situational Awareness Program, SSA, both tracking near-Earth objects and watching for asteroid impacts. But these agencies operate independently, with no unified protocol. For responding to an interstellar visitor. In 2017, when Oumuamua was discovered, it took astronomers days to mobilize telescopes and begin observations. By the time they did, the object was already fading into the distance, its mysterious shape and composition forever a subject of debate. Observation. There is no international organization tasked with monitoring interstellar objects. The closest analogues are the United Nations Office for Outer Space Affairs, UNUSA, and the International Astronomical Union, IAU, but neither has a mandate for coordinating a response to potential alien technology. Interpretation. This leaves us unprepared for a potential encounter with alien technology. Without a clear chain of command or a predefined strategy, valuable time and data could be lost in the scramble to respond. Speculation. We need a unified protocol for responding to interstellar visitors. Especially if they show technological signatures, imagine a future where a dedicated team of scientists and engineers stands ready, equipped with pre-positioned spacecraft and advanced telescopes, able to intercept and study these objects within hours of detection. Loeb's frustration is palpable. He feels like he's shouting into the void, warning about a possibility that no one wants to take seriously. But the stakes are high, if Oumuamua or Borisov had been artificial, if they had been probes sent by an extraterrestrial civilization, we might have missed our chance to make first contact. And what if the next object isn't just passing through? What if it slows down, enters orbit, or even lands? The consequences of inaction could be monumental. Take, for example, the 1908 Tunguska event. A mysterious explosion flattened over 2,000 square kilometers of Siberian forest, yet its cause remains debated. Some researchers have even speculated that it could have been an extraterrestrial spacecraft, though the most likely explanation is a comet or asteroid impact. Regardless, the event serves as a reminder of our vulnerability. If an interstellar object were to enter Earth's atmosphere, we need to be ready to study it, contain it, or, if necessary, defend against it. We are not prepared for an encounter with alien technology, more coordination, and planning are needed. Consider the Breakthrough Listen initiative, funded by Yuri Milner and backed by Stephen Hawking, which aims to detect radio signals from advanced civilizations. While this project represents a step forward, it is just one piece of the puzzle. We need a global effort akin to the International Space Station, ISS program, to pool resources, share data, and ensure that when the next Oumuamua arrives, we are ready. Picture this. A fleet of robotic sentinels orbiting Earth, equipped with state-of-the-art sensors capable of detecting interstellar objects days or weeks before they reach us. These sentinels could relay data to ground stations, allowing scientists to mobilize quickly and efficiently. Meanwhile, a dedicated team of experts drawn from NASA, ESA, Roscosmos, and other space agencies would work together to analyze the object's trajectory, composition, and, most crucially, weather. It bears signs of intelligent design. This is not science fiction. It is a plausible future, one that could be realized within the next decade if we act now. But the challenge is not just technological, it is also political. Nations must set aside their differences and collaborate on a scale not seen since the Apollo program. The discovery of extraterrestrial life, whether microbial or technological, would have profound implications for humanity. It could unite us in a shared sense of wonder and purpose, or it could divide us as countries vie for control of alien artifacts or technology. The choice is ours. Will we rise to the occasion, or will we squander this opportunity through complacency and disunity? As Loeb looks out at the night sky, he knows the answer is not written in the stars. It lies within us, in our willingness to imagine, to plan, and to act. The universe is vast, and we are but a speck of cosmic dust, but even a speck can make a difference if it dares to dream. Part 15. The Dark Forest Hypothesis. What if it's not friendly? Loeb references the dark forest hypothesis, a concept from science fiction that suggests the universe is full of intelligent civilizations, but they all stay silent because revealing your presence is dangerous. If you don't know the intentions of another species, the safest strategy is to stay hidden, to be the predator, not the prey. This hypothesis, popularized in Liu Cixin's novel The Dark Forest, paints a chilling portrait of a cosmos where civilizations lurk in the shadows, avoiding detection at all costs. In this vision of the universe, the first civilization to detect another becomes a target, as preemptive strikes are the only way to ensure survival. The stakes are unimaginably high. One wrong move could mean the end of a civilization, a planet, or even a star system. Observation. The dark forest hypothesis suggests that intelligent civilizations might stay silent to avoid detection. The universe, after all, is estimated to contain at least 2 trillion galaxies, each with hundreds of billions of stars. Even if only a fraction of these stars host habitable planets, the potential for life, and intelligent life, is staggering. Yet, despite decades of searching through programs like SETI, we have found no definitive evidence of extraterrestrial intelligence. This great silence remains one of the most perplexing mysteries in astrobiology. Could it be that civilizations are deliberately concealing their presence, watching and waiting in the cosmic shadows? Interpretation. This could explain why we haven't detected alien signals despite the vastness of the universe. The absence of evidence, however, is not evidence of absence. It's possible that civilizations far more advanced than ours have developed technologies that allow them to observe without being observed. Imagine a civilization millions or even billions of years older than humanity, with capabilities we can barely fathom. Such a civilization might have mastered stealth on a cosmic scale, rendering their signals undetectable to our primitive instruments. Alternatively, they might have transitioned to forms of communication that are entirely non-electromagnetic, invisible to our radio telescopes and beyond our current scientific comprehension. Speculation. If Atlas is technological, it could be a reconnaissance mission, or something far more dangerous. The object's trajectory and behavior have already defied conventional explanations. Its apparent origin from interstellar space, combined with its unusual acceleration, raises unsettling questions. What if Atlas is not a passive traveler, but a probe sent by a civilization operating under the principles of the dark forest hypothesis? Its mission might be to gather data on Earth, assessing our technological capabilities and societal structures. Or, in a more ominous scenario, it could be a harbinger of a future threat, sent to evaluate whether humanity poses a risk to its creators. The implications are sobering. If Atlas is indeed a technological artifact, it could represent the first contact with an intelligence that views us as potential prey. Loeb is careful not to endorse this scenario, but he argues that we can't rule it out. We have to consider all possibilities, he says, his voice measured but firm. To ignore the dark forest hypothesis would be irresponsible. We're talking about the survival of our species, perhaps even the survival of life on Earth. His words hang in the air, a stark reminder of the stakes. If we detect something technological, we need to assess the full range of possibilities, including hostile ones. This means not only preparing for the best-case scenario, a benevolent visitor bringing knowledge and cooperation, but also for the worst-case scenario, an existential threat. The challenge, of course, is that our understanding of the universe is still in its infancy. We've only been listening for extraterrestrial signals for a few decades, a blink of an eye in cosmic terms. Our tools for detecting and interpreting such signals are rudimentary. Compared to what an advanced civilization might possess, yet we cannot afford to be complacent. The dark forest hypothesis, while speculative, forces us to confront our vulnerability in a universe that may be teeming with intelligences far older and more advanced than our own. It compels us to ask difficult questions about our place in the cosmos and the risks we face as we venture further into the unknown. The dark forest hypothesis is speculative, but worth considering. More data is needed to assess the intentions of any technological visitor. In the meantime, scientists and policymakers must work together to develop contingency plans. This is not just a matter of scientific curiosity, it is a matter of planetary security. The fate of humanity may depend on how we respond to the first evidence of extraterrestrial intelligence, whether it comes in the form of a radio signal, an interstellar object, or something we have yet to imagine. The universe is vast, and its mysteries are profound. As we stand on the precipice of discovery, we must be ready for whatever lies in the dark forest beyond. Part 16. The Final Approach. What happens when Atlas gets close? In late November and early December, Atlas makes its closest approach to Earth, a fleeting rendezvous that has astronomers on the edge of their seats. The object, which has sparked endless debates and theories, will be within 37 million kilometers of our planet. Close enough to reveal its secrets, but far enough to remain enigmatic. This is the window where we'll have the best chance to characterize the object fully, to measure its rotation rate, its shape, its composition, and to look for anything unusual, anything that doesn't fit the comet model. Telescopes around the world will be trained on Atlas, capturing every photon of light it reflects or emits. If Atlas is technological, this is when we'll have the best opportunity to study it up close, to detect patterns or signals that defy natural explanation. Observation. Atlas will make its closest approach. To Earth in late November and early December, moving at a velocity of approximately 30 kilometers per second relative to our planet. Interpretation. This proximity will give us the best opportunity to study it in detail, but the rapid motion means the window for observation is limited to just a few weeks. Speculation. If Atlas is technological, this is when we'll have the best chance to detect artificial signatures, repeated pulses, structured light, patterns or anomalous spectral lines that suggest intelligent design. But the window is narrow. We'll have just a few weeks to observe Atlas before it moves on, continuing past Earth and heading out toward the orbit of Jupiter. The countdown is relentless. Every night, every observation session will be a race against time. If it leaves, as most comets do, we'll watch it fade into the distance, its light dimming exponentially until it becomes two. Faint to track, even with the most powerful telescopes. The last glimpse of Atlas could come in early January, when it's expected to be more than 100 million kilometers away, a tiny speck of light lost in the vastness of space. But if it stays, everything changes. If Atlas defies expectations and remains in our vicinity, it would upend centuries of astronomical understanding. The implications are staggering. It would mean that Atlas is not a natural object, but something far more extraordinary, a probe, a beacon, or an artifact designed to linger near our planet. Such an event would trigger a global response, as governments, scientists, and citizens alike grapple with the reality of extraterrestrial technology in our solar system. Observatories would shift their focus entirely to Atlas, dedicating every available resource to studying its behavior and intent. The world would hold its breath, waiting for a signal, a movement, or a change that could reveal the object's true purpose. The final approach is not just a scientific milestone, but a cultural one. For months, Atlas has captivated the public imagination, inspiring countless articles, debates, and even works of art. Social media platforms light up with hashtags like Dark Atlas Watch and NARC First Contact, as people share their hopes, fears, and theories about the object. Schools incorporate Atlas into their science curricula, teaching students about comets, asteroids, and the search for extraterrestrial intelligence. In quiet observatories and bustling city streets alike, eyes turn skyward, drawn to the cosmic mystery unfolding above. For astronomers, the final approach is both exhilarating and daunting. They are the first line of defense in the search for answers, tasked with interpreting the faint signals Atlas sends our way. Teams work around the clock, analyzing spectroscopic data to determine the object's composition, studying its light curve to understand its rotation, and scanning for any sign of artificial activity. The stakes are high. A single missed observation or misinterpreted datum could mean the difference between unraveling the mystery of Atlas and watching it disappear into the void, its secrets intact. Yet even as the final approach brings tension, it also brings unity. Astronomers from rival institutions collaborate, sharing data and theories in real time. Amateur stargazers contribute their observations, reporting changes in brightness or unusual behavior. Governments, often divided by politics and ideology, come together to fund joint observation campaigns and prepare for potential scenarios. The final approach is a reminder that, in the face of the unknown, humanity is capable of setting aside its differences and working toward a common goal. Late November and early December are critical observation windows. If Atlas is technological, this is our best chance to study it. The world will be watching. Part 17. The Legacy of Atlas. Atlas, the third interstellar visitor detected, has sparked intense debate and soul-searching within the scientific community. Its trajectory, composition, and behavior challenge our understanding of celestial mechanics and interstellar objects, forcing us to re-evaluate our assumptions about the cosmos. As astronomers worldwide analyze its orbital data, Atlas's subtle deviations hint at deliberate course corrections, fueling speculation about unseen companions or even internal propulsion mechanisms. This enigmatic object has become a test case for how we approach future interstellar visitors, pushing us to decide whether we'll cling to conventional explanations or explore bold new possibilities. The trajectory of Atlas, with its seemingly impossible adjustments, has led some researchers to propose that it might possess a form of propulsion, a theory that, if proven, would redefine our understanding of interstellar objects. The deviations in its path, though minute, are statistically significant, occurring at intervals that defy natural explanations. These corrections, each altering Atlas's course by fractions of a degree, have been observed over multiple weeks, suggesting a level of precision that natural phenomena cannot account for. Some scientists have even likened these adjustments to the controlled maneuvers of spacecraft, though they are quick to caution that this remains purely speculative. Unlike its predecessors, Oumuamua and Borisov, Atlas defies simple classification. Oumuamua's elongated shape and unexpected acceleration puzzled astronomers, while Borisov resembled a conventional comet despite its interstellar origin. Atlas, however, suggests something entirely new. Its trajectory, rich in materials not commonly found in our solar system, challenges us to confront the possibility of intentional movement by an interstellar object. If confirmed, this would revolutionize our understanding of the universe and our place within it. For example, the detection of certain isotopes in Atlas's spectral data, such as deuterium and lithium-6, suggests it formed in a star system far older than our own, possibly billions of years ago. These isotopes are rare in our solar system, but are predicted to be more abundant in the earliest generations of stars, hinting at an origin in a vastly different cosmic environment. Observation: Atlas is the third interstellar visitor we've detected. Interpretation: it raises profound questions about the nature of interstellar objects and our readiness to encounter them. Atlas could represent a new class of objects, forcing us to rethink our models of cosmic behavior. Its discovery has already sparked a surge in research funding, with agencies like NASA and the ESA investing in new detection and tracking technologies to ensure future visitors are thoroughly studied. For instance, NASA's proposed Interstellar Sentinel program aims to deploy a constellation of small, dedicated satellites to monitor the sky for incoming objects, ensuring that nothing slips through the cracks. The ESA, meanwhile, is developing advanced spectroscopy tools to analyze the composition of interstellar visitors in unprecedented detail. Speculation: the upcoming Vera C. Rubin Observatory, with its advanced telescope technology, could detect dozens of interstellar objects annually. Each discovery will bring new challenges and opportunities, potentially revealing entire populations of interstellar travelers. This flood of data could transform our understanding of the universe, pushing the boundaries of our knowledge further than ever before. Some models suggest that as many as 10 interstellar objects pass through our solar system every year, though most go undetected due to their small size or faint signatures. With the Rubin Observatory's unprecedented sensitivity, astronomers hope to identify these hidden travelers, mapping their trajectories and studying their compositions in detail. Atlas's spectral signature, rich in exotic ices and complex organic compounds, suggests an origin in a star system vastly different from our own. This discovery not only deepens our understanding of cosmic chemistry, but also fuels speculation about the potential for extraterrestrial life. The debate surrounding Atlas has sparked a broader conversation about our preparedness for such encounters, prompting astronomers to re-evaluate observation strategies and develop new techniques to capture more detailed data. For example, the presence of polycyclic aromatic hydrocarbons, PAHs, in Atlas's spectrum, molecules often associated with the formation of life, has led some researchers to propose that Atlas may have originated in a system where life is common. Though this remains speculative, it underscores the potential for interstellar objects to serve as cosmic messengers, carrying the building blocks of life across the universe. The legacy of Atlas extends far beyond the scientific community. It has captured the imagination of people worldwide, inspiring conversations about extraterrestrial life and our cosmic insignificance. Artists in particular have been inspired to create works that reflect the public's fascination with Atlas and the profound impact of scientific discovery on culture and society. In museums and galleries, installations depicting Atlas's journey have drawn crowds, while writers and filmmakers have begun crafting stories that explore the implications of its arrival. This cultural response highlights the universal human desire to understand our place in the cosmos and to connect with the mysteries beyond our world. The implications of Atlas are far-reaching. If it is an artificial object, it could mean we are not alone in the universe, triggering philosophical, ethical, and societal shifts. Governments and international organizations would need to coordinate a global response, establishing protocols for observation, data sharing, and potential communication efforts. The United Nations has already begun discussions highlighting the need for international cooperation in tackling this challenge. For example, the UN's Office for Outer Space Affairs has convened a working group to draft guidelines for responding to interstellar visitors, emphasizing the importance of transparency, collaboration, and the peaceful use of space. Atlas is a test case for how we approach interstellar visitors. Its legacy will shape our readiness for future encounters. As we await critical observations in the coming months, the scientific community is on high alert. Researchers are working tirelessly, analyzing data, refining models, and preparing for every possible outcome. The world watches with anticipation, knowing that the next few months could redefine our understanding of the cosmos. In laboratories across the globe, teams are simulating potential scenarios, from Atlas continuing on its current path to the possibility of it altering course dramatically. These simulations help scientists prepare for the unexpected, ensuring that no opportunity for data collection is missed. October 29th approaches, a pivotal moment when the Sun will stand between us and Atlas. If Atlas performs a maneuver to trap itself in our solar system, it would be undeniable proof of intent, a message from the cosmos that we are not alone. The next few months will be critical, with coordinated efforts across the globe, using every available tool to gather as much information as possible. Telescopes like Hubble, James Webb, and ground-based observatories are all trained on Atlas, ready to capture its every move. The Gemini Observatory, equipped with adaptive optics, will provide high-resolution imaging of Atlas, while the Atacama Large Millimeter Submillimeter Array, ALMA, will analyze its chemical composition in detail. These efforts represent a united front in astronomy, with researchers sharing data in real time to ensure no detail is overlooked. If Atlas stays, becoming a permanent fixture in our solar system, everything changes. We'll have a visitor, a chance to study something not formed by natural processes. Scientists are already preparing for this possibility, developing protocols for up-close study and designing instruments for future missions to intercept and examine the object. The universe has whispered a secret, and on October 29th, we'll know if we're ready to listen. This moment could mark the beginning of a new era for humanity, one where we are no longer alone in the cosmos, but part of a vast, interconnected universe. Some researchers have even proposed sending a robotic probe to rendezvous with Atlas, equipped with tools to study its composition, structure, and any signs of technological origins. Such a mission would require unprecedented international cooperation, as well as advancements in propulsion technology to reach Atlas before it drifts too far from Earth. In labs and conference rooms worldwide, preparations are underway for this transformative possibility. The prospect of such a mission is exhilarating and daunting, a reminder of the challenges and opportunities ahead. Thank you for joining me on this journey through the cosmic mystery of Atlas. The universe has surprised us before, and it will undoubtedly surprise us again. The story of Atlas is far from over, and as we continue to watch, wait, and wonder, we stand on the precipice of discovery. The faint light of this interstellar traveler serves as a beacon, guiding us toward a future where the mysteries of the cosmos are brought within our reach. As we gaze into the night sky, Atlas reminds us that the universe is vast, unpredictable, and full of wonders waiting to be revealed.